Hey there. So in today's video we will talk about DIAC. The whole video is based on the experiment DIAC, the theory of the DIAC, and the hardware practical we will perform. In the starting of the video we will see the theory of the DIAC, what actually DIAC is and what are the uses of DIAC. And so first of all we will see what is DIAC, the meaning of the DIAC. Here the symbol of the DIAC, the characteristics of the DIAC, and the graph of the DIAC. Let's move forward to the basic theory and then we will start the practical. Enjoy the video. DIAC belongs to the thyristor family. It does not have a controlling gate terminal because they can be turned on or off by simply reducing the voltage level below the avalanche breakdown voltage, and it can be done in both the polarities. DIAC is given by the symbol of two diodes connected in parallel and opposite to one another and has two terminals. Since the DIAC is bidirectional, we can't name those terminals as anode and cathode. The terminals of DIAC are simply called A1 and A2 or MT1 and MT2, where MT stands for main terminal. DIAC can be turned on by either a positive or negative half cycle of an AC voltage. For the positive cycle of AC voltage, if the applied voltage is less than the forward breakdown voltage, a very small current called the leakage current flows through the device. This current is produced due to the drifting of electrons and the holes at the depletion region and is not sufficient to cause conduction. Hence, the DIAC remains in the non-conducting mode called the blocking state or off state. As soon as the applied voltage reaches the breakdown voltage VBO, the device starts conducting. The current through the device starts increasing and the voltage across it starts decreasing. The region in the conduction state, there is no control over the breakover voltage, for the DIAC remains unchanged as the gate terminal is absent here. The characteristics of the DIAC are very much similar to that of the TRIAC. For the positive half cycle of the AC supply, the characteristic is obtained in the first quadrant and a similar characteristics of the negative half cycle is obtained in the third quadrant as shown in the figure. The breakover voltage of a DIAC ranges from 28 volts to 42 volts. The typical turn on time ranges from 50 to 500 nanoseconds. The turn off time is much longer, about 100 nanoseconds. The applications of DIAC is used in lamp dimmer, fan speed regulator, and temperature controller. Also, the disadvantages of DIAC is it is low power device. It does not have a control terminal. Now we are performing forward bias. As you can see, we have connected the power supply. The middle one is ammeter and the rightmost is voltmeter. We have connected the circuit diagram on the breadboard, and you can see that if we are rotating the knob, the voltage in the power supply and the voltmeter are getting the same readings. So make sure of that. And also we have connected the power supply 30 volts and 30 volts in series because we know that the triggering point of DIAC is above 30 voltage. So for that we connected the power supply in series. So here you can see that after increasing the voltage, the current is increasing very slowly, and we need to find out VBO, the breakover voltage, through which we will see that the current will increase rapidly and the voltage will decrease. So here we go. You can see that the current is increasing very slowly. From here we can see whenever the current will increase rapidly, we can see that that will be our triggering point. So 29.8 volt was our triggering point, and here current increased rapidly. So we have performed forward bias. Let's go to reverse bias. Here, this is the voltmeter, this is the emitter, and this is the power supply. And in reverse bias, we just have to reverse the power supply. Here you can see the negative sign in the voltmeter shows the reverse bias, and we have to perform it same as the forward bias. And we are increasing the voltage, and from here we can see that 29.07 volts is our triggering point, and if noted the readings, we can plot the graph easily, and hence the IV characteristics of DIAC is being performed.